Now, it's possible that we can factor the denominator and one of the factors is quadratic and it will not factor anymore. When we set up the partial fractions, this is going to be a little bit different then. We're going to have our x plus 1 and our x squared plus 4. And then that's going to be equal to, we're going to set one of these up with an x plus 1, but the other denominator is going to have an x squared plus 4. And because this is quadratic, there's a possibility that there could have been an x term up here. So we need to set this up as bx plus c. So numerator will need an x term when the denominator is an unfactorable quadratic. Now as we go to do this, we will continue with the same process. If we clear this of fractions, we multiply everything by x plus 1, x squared plus 4. The x plus 1's will cancel, and this will leave an x squared plus 4. And on this one, the x squared is plus 4 cancel, and this will leave an x plus 1. So in writing down what we have, we've got 1 equal a multiplied by x squared plus 4 plus bx plus c multiplied by x plus 1. Now, convenient x isn't going to be as convenient with this one because we have this x squared. If we tried to zero this out, it would be an imaginary number. We're not going to go there. We are going to instead use the method of equating coefficients. So when I have this quadratic factor in here, then I typically will go to equating coefficients. So what I'm going to do is I'm going to multiply everything out. So I'm going to get rid of all of these parentheses by distributing here. And I'm going to FOIL this. So this is going to be bx squared plus bx plus cx plus c. And then I'm going to use the idea that the only way that two polynomials could equal each other is if the coefficients on each side are equal. So in other words, I see x squared terms. Coefficients on the x squareds on the left-hand side will need to equal coefficients of x squareds on the right-hand side for this to be equal. So looking on the left-hand side, I'm looking at the x squareds. There are no x squareds on the left-hand side. On the right-hand side for coefficients, I have a plus b. Now I'm going to look at the x's. There are no x's on the left-hand side. On the right-hand side, I have a b plus ac. And then finally, I'm going to look at the constants, and constants being no x's in them. On the left-hand side, I have a 1. On the right-hand side, I have a 4a plus c. So what happens after I equate coefficients is I'm left with 3 equations here that I can solve simultaneously in some way. A matrix would work if I need to. These are actually simple enough that I think I'm just going to simply do some substituting. So it looks like a would equal negative b. As I look here, I could actually put that c would also equal negative b. So if I'm looking at this particular equation right here, I could substitute in for a and c, and I'd have 1 equal a is negative b, so that's negative 4b, and c is also negative b. So combining those, I would have 1 equal negative 5b, so b must be negative 1/5. Well, if a is negative b, then a must be 1/5, and c is negative b, so c must also be 1/5. So I just did that by a substitution because they were pretty simple. Now let's go ahead and express our integral then. We've got a being 1/5, so this is going to be 1/5 over x plus 1. And then plus b was 1/5, so 1/5 x, and c, no, b was negative 1/5, so I'll put a negative on there, and c was 1/5, so plus 1/5 over x squared plus 4 dx. Now I'm going to get rid of my partial fraction work so we can see about finishing this integral. So as I look at this to integrate, I can handle this first term. That's going to be 1/5 times the natural log of x plus 1. But what am I going to do with this? Well, I can go ahead and split this up into two other fractions, one of them with this numerator and the other with this numerator. So that's what I'm going to do. So I'm going to have the integral of negative 1/5 x over x squared plus 4 plus the integral of 1/5 over x squared plus 4. I left off my dx here. dx. So we can always do that when the numerator is two terms. We can write the denominator under each one. And in doing that and looking to see what I have left to do, I can see that I can integrate each one. This one I can do a u substitution. So I will let u be x squared plus 4. And then du is going to be 2x dx. And so I can make that a 1/2 since I don't have the 2 there. And then here is my x dx. So this one is going to be, and maybe we'll just kind of continue working it down over here. So I'm going to have integral, and we'll go ahead and put this negative 1/5 out of the way. So my x dx is going to be 1/2 du, and then I'm just going to have 1 over u. So that is going to be negative 1/10 times the natural log of u, and then we can go ahead and replace with our x squared plus 4, which is always positive. So let's go ahead and write down what we have so far over here on the other side. So we have 1/5 natural log of x plus 1 minus 1/10 natural log of x squared plus 4. And now we still have to deal with this one. And if we can recognize this one, that's great. If we're not sure what to do with it, we can always go back to our trig substitution and sketching a triangle. So let's go ahead and make our triangle. And let's label the sides so that we have x here, 2 here. So this would be the square root of x squared plus 4. Here's our theta. So tangent theta is going to be x over 2. So our substitution is going to be x equal to tangent theta. And dx then would be 2 secant squared theta d theta. I'm going to go do this over here on the left hand side. So we're going to put our 1/5 out in front and then integrate here, and our dx is 2 secant squared theta d theta, and then in our denominator we have 4 tangent squared theta plus 4. So this is going to be 4 tangent squared theta plus 1. And we know that we can replace that with secant squared theta, and that will cancel with our secant squared theta up here. This 2 will cancel and leave me a 2 in the denominator. And so what I have, I'll go ahead and bring this 2 in the denominator out in front. So that's going to be 1/10 integral of what essentially is left here, just d theta. So that's going to be 1/10 theta. And now getting this back in terms of x, if I come over here to get theta alone, I would take the inverse tangent of both sides. So theta is going to be inverse tangent of x over 2. My solution here, it looks like I have plus 1/10 tan inverse of x over 2 plus a constant. Now if you recognize this as an inverse tangent and could just do that, that's fine, but I'm trying to have us practice some of these skills we've learned. If you don't recognize those, have this whole integral table memorized, that you can draw your triangle and you can get at it.